Thank you. Oh, this is interesting. Okay, maybe there's a... All right, Worldcoin. So some of you may have heard of it. Some of you may have seen the shiny metal spheres that we have in various places. But a little bit of a recap of what the project is about. Introducing Worldcoin. So the idea was to address the impending big global income problems that we're having by addressing it head on and finally creating this global inclusive financial ecosystem that we're all started the whole blockchain adventure for. One of the the reason we need to do this now is because, of course, artificial intelligence is happening. It is going to disrupt a lot of stuff. It's going to make it hard to distinguish humans and bots online. We need to solve this, and that requires solving for humanness. We now have the technology to prevent double spending and global distributed consensus and all that. But what is missing is a way in the digital domain to represent human beings. After a lot of research, we came up with this hardware biometrics device you see over there called the Orb. I won't go into the details of that. That will be a separate talk. We've also built an app that goes with it that is essentially a nice, user-friendly self-custody wallet. But it also supports something we call World ID, which is a proof of personhood protocol that is fully privacy and anonymity preserving. Sorry, I think the background is a little bit awry here. Anyway. We've since, through hackathons and other venues, got a lot of projects that have experimented with proof of personhood. There's a lot of things you can do with it. It's sort of an unlocking primitive that once you add it, just like global consensus, it allows you to build things that were just simply impossible to build before, like one person, one vote, for example. Or doing airdrops that are completely fair and equitable to all humans. We've also been rolling this out for a while. We now have 2.5 million unique users signed up, and we know for sure that every single one of them is a unique human, and there's no symbols in here. We are active in 155 countries and rapidly growing, and we have 600,000 monthly active users, so people that do transactions in the app every month. Now, this is just a start. 2.5 million is a far cry from a global inclusive financial system, so we want to get to 1 billion users at least, 10 billion ideally. For that, a lot of things need to happen. We need to have a blockchain that can actually support this. So this has been a focus for the R&D team for quite a while, actually, since inception. We want it to be secured with a level that makes sense, like at least Ethereum levels of security. In the very early days, we were experimenting with a little-known L2 implementation called Hubble, which is funny. It's an optimistic rollup that uses BLS signature aggregation. And that one actually got kind of the best of both worlds between the ZK rollups and the optimistic rollups, and it got you down to the lowest cost you could possibly get across all approaches. The downside is that, like many of the ZK rollups at the time, it didn't support full EVM semantics, so you were limited to doing transfers. And ultimately we decided that this is not going to be the future. The future is going to be having a rich DeFi ecosystem where many people can do all sorts of cool things and build upon each other's work. That led us to solving the problems we have with EVM-based solutions. The biggest one, of course, is the cost of call data. So a year and a half ago, we helped out with EIP 4844 and implemented the backend for the KCG ceremony that now collected more than 100,000 users that contributed their entropy to building like a secure 4844 implementation in probably the next half year or so. We also deployed our wallet with our pre-launch users, which was already more than 1 million. on an EVM testnet, and we want to have account abstraction and all the nice things that you need to make wallets user friendly. So we used Gnosis Saves. We deployed Gnosis Saves for all our users. The discrepancy you see between like the 1 million plus users and the 600K saves is that we also have users that signed up when it was still a testing web page, and there's various users that are all grandfathered in at various stages of the project. Users can have balances in multiple currencies, but what was it? 7 months ago, it was time to finally go into production and launch. The decision was made to launch on Optimism mainnet because we are aligned with the superchain vision and wanted to be an EVM L2 attached to Ethereum. Then we had the job of migrating all of this over. So we're on this other network, and now we have all these users. They're all self-custody. We cannot move their stuff for them. So what we did instead is we set up a backend service that once we update the app, it will give you the option to migrate your wallet. When users do that, it will send the funds to a receiving contract, and then our backend would deploy a new Gnosis Save on OP mainnet and issue them the funds, and essentially running a little bridge there. Now, you may have seen some statistics on Twitter about how suddenly there were a whole lot of Gnosis Saves on in the Ethereum ecosystem. That's basically us. Like, we've deployed 600,000 Gnosis Saves in a week's time before launch, and we've deployed probably more than 1 million since. So we're big consumers of Gnosis Saves there, which is great. They're amazing. How did launch day go? This is interesting. So this is a graph of the first couple of weeks after launch day, the activity. So the number of claims that users made, the number of transfers between wallets that users made, and the number of swaps, like trading between token pairs that users did. Those are the 3 main transaction types that the wallet supports at the moment. On launch day, it looks kind of hectic because it went super hectic. The red stuff basically means chaos, reverting transactions, things not going the right way. We also hit gas limits. The blockchain halted. Some of the service providers that we used had their services crash and needed to do some emergency debugging. So that was interesting. Like, clearly, just I think it was 1.5 million users at launch. Clearly, that is already an amount of load that we're just simply unprepared for in our infrastructure. So that was a big lesson there. We got the infrastructure up and running, and then by the time the second airdrop went, like, this app has this kind of cadence where you can periodically claim some tokens in some jurisdictions. That's the cadence that you see here. The second airdrop, which was actually more users, went a lot smoother. We still hit, I think, a 6-hour outage, just simply due to chain congestion. But we at least got services running reliably. Now, the second graph to look at, and one thing to keep in mind is that this is Gnosis Saves, so it doesn't matter who sends the transaction and pays for the gas. The user only needs to sign the transaction. And we use this to subsidize user transactions. Because our thesis is that like 15 cents for a transaction is still way too expensive. We need to get down to like 1 or 2 cents per transaction before this is actually a fee that we're willing to pass on to our users. We also want to know, like, hey, what does this future look like once we have scaling, and start from the mindset that we're in this future where we have these cheap transactions and build for that. So we are subsidizing the fees at the moment, and we analyzed, okay, what does this cost us? And that resulted in this graph where you can see the ETH burn per day. During launch, it was off the charts, huge amount of ETH burn per day, but as we went on, we started optimizing lots of things. I'll get into the details of how we did that in a moment, but you'll see that even though the number of users just keeps growing and the activity keeps growing, our actually fee expense goes down quite drastically. The other thing that is really important to note is it's broken down into L1 fees and L2 fees. So in any roll-up, data is published on L1. All the transactions are published on L1. This costs call data on L1. This call data is priced in L1 gas. Then all of the opcodes and things that you execute in an L2 transaction, they are priced in L2 gas. So you can break it down in like, how much are you spending in L1 gas, which is purely the call data, how much are you spending in L2 gas, which is essentially everything else. Then you can correct that for the different prices. L2 gas is a lot cheaper than L1 gas. And you get to this graph. And what you'll see is that basically 90% of your expense is just call data. Not fees you're paying to your L2 chain. It's just pure L1 call data. That is the dominating factor here. And that also leads to kind of the first idea, like, hey, can we use more compute in order to pay to generate less call data? Like, can you essentially compress transactions? Well, the good thing is we were already using Gnosis safes, and since these are meta transactions essentially, and it doesn't matter who sends them, you can do multiple of them together in a single transaction. So the first trivial thing we did is we started a batching service that would aggregate a number of these transactions. Then it would use the multi-call contract to call out to all these Gnosis safes and execute these transactions one by one, which resulted in already a substantial saving because there's a rather large per transaction overhead that now gets amortized over multiple transactions. The next thing we did is instead of using multi-call, we wrote our own contract in plain YOL, and this is interesting because since these are Gnosis safes, it's essentially trustless. The safe contract verifies that the transaction is entirely correct. So anything you can put in between, at worst, can like drop the transaction. So there's a censorship risk, but it can never manipulate the transaction because then the signature would be invalid. So you can kind of do whatever you want in terms of compression, decompression in between. So we wrote some really exoteric YOL code that uses code copies and fancy things you can't even do in Solidity assembly in order to decompress these transactions as good as possible. And for the claims, which because of the anonymity and privacy you have, uses zero knowledge proofs and GROT16 proofs, we did some moon math to compress these down to half the size. So now we're in a situation where we can have a single transaction that contains 10, 20 different users claiming an airdrop using GROT16 proofs that are only half the size of GROT16 proofs on Ethereum L1. This led to massive amounts of savings. So think in total about 2/3 less than we would otherwise pay. That's the main takeaway. That's where we are now. Now, the next steps. This is on OP mainnet. Right now we have Superchain being developed. We have Base that has launched since. And it makes sense for us to do the same for a variety of reasons. Mostly to provide our users with higher gas limits, lower fees, and cheaper call data. So what would we need for this Worldcoin superchain? Well, first of all, we need to raise the gas limit because we already see that with our current user load, you'll hit this limit at peak hours, and then the app just becomes unavailable. It just says your transaction is queued. It will get there when it gets there, and it takes however long. Once we get to 10 million users, this will be more than annoying. So that needs to be solved. That's a much harder problem than it seems at first glance, because this gas limit, the reason why it is where it is a little bit of a dark art, where people benchmark nodes, and they look at like how many gas of transactions can this process, and you'll see that, well, my node can easily handle like 100,000 times what the gas limit is. The problem is that that is not what you need to be optimizing for. You need to be optimizing for the absolute worst case. Like, let's say an attacker that wants to take your chain down is going to find the one opcode that hurts the most for your sequencers, and is going to make transactions that fill the entire block gas limit using just that single opcode repeated, doing the thing that hurts your node the most. So you're not optimizing for expected case performance, which is what we do 99.9% of the time in software engineering, and we have all sorts of benchmarking tools there. We are optimizing for worst case performance, which is a much, much harder game, where you need to find out what is the biggest pain point in the code. So we need to set up better processes to figure out what are the pain points in nodes, and then we can address them one by one. Then we have a better understanding of what the worst case is, and then we can start raising the gas limit. Next thing, of course, cheaper call data. I think this has been mentioned several times now in the past hour, but yes, we need 4844, we need eigenlayers, we need Celestia, we need all sorts of alternative data availability layers, because it's just not going to happen with Ethereum L1 call data. Another interesting question around Superchain is, if you become part of the Superchain effort, it essentially means handing over control of the chain to the community. The chain itself now becomes community property, managed by the community, governed by the community, and all changes that are made to it need to be approved by the community. This is important because this guarantees actual decentralization. This means that no organization that can build a superchain can rug pull you or do things that make it incompatible or in other ways hurt the users. So that makes a lot of sense, but it also means that we need to get good consensus and a community with values enshrined that align up with the goals of building this billion user chain. So that's where we are now. One of the things, a little teaser of what we're going to be doing next is we might soon announce a grants program to grow the ecosystem of people joining our effort to build out this billion user chain, but also to further develop the project. One of the things we'd like to see is third-party wallets, third-party orbs even, if people are good with the soldering iron. An important thing for the proof of personhood identity element is fast mobile provers. There's been a lot of ZK roll-up motivated research now in how we can do ZK proving really fast on gigantic AWS clusters. We've kind of forgotten the original privacy application of ZK proofs, and they require users to be able to run it themselves. So like, how can we get faster provers on your mobile phone? Which is an interesting challenge. And another thing, Roberto also mentioned it, we need more infrastructure around L2s and kind of the OP stack. There's a lot of work there to be done, so that will be interesting to work on as well. Now, if you're interested in picking us up on any of these challenges, do reach out. And that's it for me. Are there any questions? Okay, thank you.